Dear students, welcome to lecture 5 part 2. In this lecture we will discuss about the distinction between illumination and shading, local and global illumination, and various types of lights. So first of all we will consider the distinction between illumination and shading models. So what is illumination? Calculate intensity at a point on surface. यानी कि एक पिक्सल की जो है इंटेंसिटी को मालूम करना और फिर ये एस्टिमेट करना कि वो कितना इल्यूमिनेटेड है और कितना इल्यूमिनेटेड नहीं है. सो व्हाट इज़ शेडिंग? शेडिंग यूजेस कैलकुलेटेड इंटेंसिटीज़ टू शेड पॉलीगॉन्स. तो शेडिंग जो है वो पिक्सल वाइज इंटेंसिटीज़ को कैलकुलेट करने के बाद शेड्स जनरेट करती है. दिस कुड बी हैपेंड ओनली यूजिंग इल्यूमिनेशन मॉडल्स. So we will review the important illumination models further in the next lecture. These could be Phong model and Lambertian model. Both were discussed in the next lecture. Dear students, hope you can easily now differentiate between shading and illumination. Illumination also affect realism. Realism means that if the object seen in natural environment must be shown as it is in the digital form. So to achieve realism, illumination plays an important role. We have already discussed about realism in the last lecture, if you recall rendering pipeline process, where we have discussed that how natural scene converted into 2D image, and there realism act as a secondary property in the capturing process. However, it is more important to be discussed. So realism can be achieved with the help of global illumination as well as local illumination. Global illumination can be achieved using ray tracing or radiosity. So first of all we will discuss about ray tracing. What is the definition of ray tracing? It is a technique for generating an image by tracing the path of the light in an image plane and simulating the effects of the encounters. यहाँ पे encounters का मतलब pixels हैं. Ray tracing को हम direct illumination technique भी कहते हैं. On the other hand, what is radiosity? Radiosity is a global illumination algorithm used in 3D computer graphics rendering. Unlike direct illumination algorithm such as ray tracing, which tend to simulate light reflecting only once of each surface, global illumination algorithms such as radiosity simulate the many reflections of light around a scene, generally resulting in a softer, more natural shadows and reflection. तो दोनों में फ़र्क ये है कि आपका जो रेडियोसिटी है ये डिफरेंट और मैनी टाइप्स की रिफ्लेक्शंस को क्या होता है प्लेन पर प्रोजेक्ट करता है, जिससे आपका इमेज जो 2D पे बनता है नेचुरल सीन से जब वो 2D में कन्वर्ट होता है तो वो ज़्यादा नेचुरल शेडोज़ को रिफ्लेक्ट करता है और रिफ्लेक्शंस को भी रिफ्लेक्ट करेगा. इसके अलावा रियलिज़म को और भी चीज़ें डिस्ट्रैक्ट करती हैं, जैसा कि शेडोज़, texture maps, bump maps, anti-aliasing, transparency, reflection maps, refractions, etc. These all were discussed. These all will be discussed in the later lectures. So what is local illumination? It is defined as how is one point of the scene illuminated directly by the light source. यानी कि एक पिक्सल जो है वो कितना अफेक्ट हुआ है लाइट सोर्स की वजह से. So for local illumination, there are certain considerations which are very important and are written on the slide. Number 1, is light source only source of illumination? Number 2, simple model lump the rest into a single ambient term. Number 3, do not account for reflections within the environment. इसमें ये क्लैरिफिकेशन दरकार होती है कि इल्यूमिनेशन सिर्फ लाइट सोर्स की वजह से ही पैदा हुई है. इल्यूमिनेशन इमेज के कितने हिस्से पर मुहित है और जो नेचुरल रिफ्लेक्शंस नज़र आती हैं वो भी इसमें मौजूद नहीं होती. सो दीज कंसिडरेशन आर वेरी डिफ़िकल्ट टू एस्टिमेट एंड मॉनिटर. नेक्स्ट इज़ ग्लोबल इल्यूमिनेशन विच illuminates the whole scene. For illuminating the whole scene, the global illumination is dependent on the local illumination model. The global illumination uses the local illumination model and the reflections of different objects to make the whole scene illuminated, which is termed as global illumination. So in summary, we can say that local illumination is the point-based illumination, that is pixel-based illumination, and the global illumination is the image-based illumination, which reflects whole image in illuminated form. So dear student, after detailed discussion on illumination and its type and shading, now we will move forward to understand lighting, its type and its effects. In this slide, you are viewing different types of lightings. Mainly there are 4 types of lighting: ambient light, directional light, point light and spotlight. Ambient light is also known as natural light. So first we discussed about ambient light, basic even illumination of all objects in scene. Simply, if we can say that ambient light means the light that is already present in a scene before any additional lighting is added. It usually refers to natural light, either outdoors or coming through windows. It can also mean artificial lights such as normal room lights. इस सारी बात को समझाने का एक ही पर्पज़ है और एक ही एग्जाम्पल है कि अगर आप रूम पर बैठे हैं, काम कर रहे हैं और अगर वहाँ पर कोई बल्ब भी रोशन है तो वो भी एम्बियंट लाइट कहलाएगा। तो इस दौरान जो भी रूम में रोशनी पैदा होगी वो एम्बियंट लाइटिंग कहलाएगी, क्योंकि वो नेचुरल है और इसमें कोई और लाइटिंग ऐड नहीं हुई। सो व्हाट इज़ डायरेक्शनल लाइट? All light rays are in parallel in one direction like the sun. So it's very easy to understand that sunlight is a directional light. Number 3 is the point light. All light rays emanate from a central point in all directions like a light bulb. इसका मतलब है कि लाइट सोर्स एक ही होता है और जब वो ऑन किया जाता है तो उससे रोशनी जो है मुख्तलिफ जगहों पर फैल जाती है। स्पॉटलाइट, point light with a limited cone and a fall off in intensity like a flashlight. स्लाइड की राइट साइड पे आपको तमाम लाइट्स की रिप्रेजेंटेशन नज़र आ रही होगी। अगर हम टॉप से बॉटम की तरफ आएँ तो टॉप पे एम्बियंट लाइट है, फिर उसके बाद डायरेक्शनल लाइट, फिर उसके बाद पॉइंट लाइट और लास्ट में आपको स्पॉट लाइट जो है रिप्रेजेंट होती नज़र आ रही होगी। मेनली स्पॉट लाइट जनरेट्स कॉनिक एंगल, also called penumbra angles, which means light start to drop off to zero here. In this slide we will discuss the effects of light, which is very important and resilient to understand. The slide is divided into 2 portions, left portion and the right portion. The left portion discusses that how light is calculated when it hits on any surface. So when we keenly observe the left portion of the slide, at the top we are seeing light, which is actually a point light, that is a bulb light, which means all rays emanate from a central point in all directions. When the light hit to the surface, the light energy divided into 3 parts. Number 1, reflected, which is shown through dotted arrow, means the light energy reflects the surface, hit and move into another angle. Whereas absorbed, it means the surface absorbed certain amount of light and then transmitted. It means the light is not absorbed by the surface, it passes through the surface. The concept is clearly shown on the diagram at the left side of the slide. At the end, you see an equation in the rectangle: light is equal to reflected plus absorbed plus transmitted. That is how actually light is computed or calculated from an object. However, at the practical point of view, we will usually consider the reflected part of the light. This can be easily viewed on the right portion of the slide. Here we have ignored the transmitted light. If we start understanding the figure, which is almost same as left figure, the point light is now called as ambient light, the reflected light is known as specular light, and the absorbed light is known as diffuse light. So the equation right below the figure, in a rectangle, light is equal to ambient plus diffuse plus specular. Ambient is the natural light, diffuse is the absorbed light, and specular is the reflected light, which is mathematically written as I is equal to Ka into Ia plus Kd into Id plus Ks into Is. I is the computed light, Ka is reflection with respect to ambient light, Kd is reflection with respect to diffuse, Ks is reflection with respect to specular light. Ia represents the ambient light, Id represents the diffuse light, and Is represent the specular light. Now further we will discuss about all three lights, ambient, diffuse and specular, in detail. Ambient light is the light in the environment evenly reaching all surfaces from all directions. Light location does not matter, eye position does not matter. Ambient light can be calculated as I is equal to Ka Ia, where Ka act as material's ambient reflection coefficient. Ambient light help to model general level of brightness in the scene. Sometimes it accounts for light effects that are difficult to compute because ambient light diffuse due to reflections. Here is the example of ambient light. You are seeing that bulb light is equally distributed throughout the room and also equally reflected from the objects and present general effect of illumination. However, few corners in the room reflects low illumination, which is the result of diffused reflections. This sometimes happened with ambient light. Next we will discuss specular light and diffuse light.